Hi, this is Dr. Goldstein, and I am going to talk about how to find the absolute value of a function. So the definition is that the absolute value of a function g of x is equal to g of x itself whenever, for those values of x, whenever the function g of x is greater than or equal to 0, and the absolute value is equal to negative g of x for those x values where g of x is less than 0. So this is similar but not quite the same as the definition of the absolute value of a number x. So the absolute value of just x itself, or actually, let me use a different letter for that. The absolute value of n, a number, is n whenever n is greater than or equal to 0, and negative n whenever n is less than 0. So here in our definition of the absolute value of a function, we're using the entire function instead of just one number. So here's a visual example to get you started understanding this, to figure out how exactly we use this definition. So I have my function f of x, and you can see that for x less than minus 3, the function is negative, because the y values are below the x-axis. Between minus 3 and 2, the value of the function is positive because the y values are above the x-axis. Between 2 and 4, the value of the function is again negative, and from 4 to infinity, the value of the function is positive. So if I were going to write down the absolute value of f of x, and remember, I don't actually know what the formula is for f of x. I just know from the picture where it's positive and negative. If I was going to write down the absolute value of f of x as a piecewise defined function, I know wherever my function is positive, I just use the regular value for f of x. And I can see from the picture that this is going to be x between minus 3 and 2. I'll clean that up a little bit. And also x greater than or equal to 4. And I need to multiply f of x by a negative sign whenever x is less than negative 3, or when x is between 2 and 4. So that is how I would actually take the absolute value of f of x, and what that is doing is, if I want to think about graphing it, all of the bits of this function that were originally below the axis get reflected above the axis. So this part down here that was below the axis from minus 3 to the left get reflected up, and also this part from 2 to 4 gets reflected up. And so this green, and then these two parts of the function stay the same. So the green line here is the graph of the absolute value of f of x. So that is a visual description of what this definition means. Let's look at an algebraic description. So in this example, we are going to take the absolute value of 5 minus 2x, and we are going to write this as a piecewise defined function, and we are going to simplify. So to start with, I can use the definition. So 5 minus 2x here, my g of x is 5 minus 2x. And so just using the definition, I have 5 minus 2x for any x values where 5 minus 2x is greater than or equal to 0, and I need negative 5 minus 2x for any x where 5 minus 2x is less than 0. So now if I take those expressions and I want to know where is 5 minus 2x greater than 0, where is 5 minus 2x less than 0, I can simplify those equations. So I look at 5 minus 2x, and I say, okay, where is that greater than or equal to 0? I can add 2x to both sides, so I have 5 is greater than or equal to 2x, and I can divide by 2, so I know that x has to be less than or equal to 5/2. And then I can also take this 5 minus 2x less than 0, and I can move the 2x over, and I can divide by 2. And so our inequality becomes, when we simplify, 5 minus 2x whenever x is less than or equal to 5/2. And again, what I did there was I took this statement and I solved explicitly for x. And then in the other half of this, we have minus 5 plus 2x, distributing the negative sign. And this is for x greater than 5/2. And again, what I did here is I took this statement and I simplified it. Let's take another look at this visually. So if I graph the line 5 minus 2x, I know that it has an intercept, a y-intercept of 2, not of 2, of 5. 1, 2, 3, 4, 5. It has a slope of negative 2. So if I go down 2 over 1, there's another point, and now I can connect these. So this is the line 5 minus 2x. Here's my x-axis, here's my y-axis. And you can see this point here is where that is equal to 0, and hopefully you believe me when I say that that's x equals 5/2, that if I stick that in there, I get 0. And so what we're doing when we take the absolute value of x is we're taking this part that is below the axis, that's negative, and we are flipping it up above the axis. So again, the part that was already positive, I leave positive. And so this green line is the graph of the absolute value of 5 minus 2x. So that is visually what we're doing when we take the absolute value. And algebraically, you have these two different conditions that you have to solve. Okay, let's see one more example to really get this algebraic part down. I want to find the absolute value of x squared minus 1. So again, just using my definition, I know that this is just going to be x squared minus 1 whenever x squared minus 1 is greater than or equal to 0, and negative x squared minus 1 whenever x squared minus 1 is less than 0. So now we have this slightly more complicated inequality, and here's how I solve that. So I look at x squared minus 1, and I want to know where is that equal to 0. And to do that, I factor, and I see that it's equal to 0 when x is 1 and when x is minus 1. So I like to use this number line approach for solving inequalities. And for example, if I plug in x equals 0, I see that 0 squared minus 1 is negative 1, so I know that x squared minus 1 is negative everywhere between minus 1 and 1. If I plug in x equals minus 2, and I can use any number to the left of minus 1, minus 2 squared minus 1 is 4 minus 1, which is 3, so I know this interval is positive. And if I use x equals 2, 2 squared minus 1 is again 4 minus 1, which is 3, and so I know that this is positive over here. Be very careful when you solve inequalities that involve anything other than a linear expression. This is quadratic, because if you're not very careful about solving these, you will miss part of it. So for example, you cannot just solve, for example, x squared minus 1 greater than or equal to 0. I cannot just take the square root of both sides and get x greater than or equal to 1. I can't do that because, for example, we can see when x is equal to minus 2, as we saw before, x squared minus 1 is minus 2 squared minus 1, which is 3, which is greater than or equal to 0. So we can see that this method doesn't work. So again, I like this number line method. It works really well. And what that tells me is that when I go to simplify my absolute value, this top part, this x squared minus 1, well, where was this expression? Greater than or equal to 0? I can either be less than minus 1, so I can be 0 or less than, and I'm positive, or I can be 1 and greater than. So that turns into this interval minus infinity. Well, let's write it in inequality notation. So x could be less than or equal to minus 1, or x could be greater than or equal to 1, and I have to use minus x squared plus 1 anytime I'm between minus 1 and 1, because that is where I need an open circle, because I don't want to include 0. That is where my function is less than 0. Again, between minus 1 and 1, not including the endpoints. Okay, so these are examples of simplifying the absolute value of a function. Again, what it boils down to is, using the definition, the absolute value of a function g of x, you don't do anything to it whenever g of x is positive or 0, and you have to multiply by negative 1 whenever your function is less than 0. That is the definition, and that is how you take the absolute value of a function.